Okay, so by popular request, here's a base station. Was it going to be the Harvard H407 in front of us, or was it going to be the Harrier CBHQ? Well, this got the thing saying yes, we'll have this one. So I bought this not too far along the line, and we're in Mr. Chippie's workshop, and bought this off eBay. And it says when you plug this into the mains, it blows all the house circuit breakers. So of course we could service this on its 13.8 volt supply. In fact, we will be doing that so we can monitor the current. But it's here in Mr. Chippie's workshop because I want him to do the capacitors in the power supply. So that's what we're going to start off with, and then we'll do it with a pat test. So are we ready to take the lid off, see whether there's any innards or whether there's been any shenanigans inside?
Extra screw there I wasn't aware of. Looks clean.
So we can't see any silliness.
Oh, there's a mouse trap.
He's just knocked the mouse trap. No, I can't see anything nasty there, but we'll be doing the power supply. Is this a 2-core or a 3-core mains lead on this one? Looks like a 3-core mains lead, doesn't it?
Yeah. Yeah, definitely. It's quite
Yeah.
nice.
So whereas the Harrier is double insulated, oh, you don't need to take the bottom off this, do you? Because it's not done like that. Yeah. Right. So what we got? I'll just move the camcorder. So the plan here is to snap one of the screw. How did that happen?
I think it looks like the controls recessed. I can see the splines.
Huh?
Oh, yeah, it's alright.
Well, when we come to sell it, it'll be glued back on. No,
Oh,
it won't.
it has. Yeah, it's snapped. So there's a piece inside.
Yeah. We won't won't say it's anything to do with the vendor. It could easily have happened in the post. So got the big electrolytic, which I think is 3300 microfarads, and then there's 2 on the sub board, and then there's some insulating tape which I've never seen before.
Hang on, what's this thing? Oh, that's a bit.
Yeah, no, yeah, it covers the on and off switch,
Yeah.
doesn't it? Right. So Mr. Chippie will get on with that, and then we'll worry about whether it blows our fuses. Right, so we've taken Royal Mr. Chippie's taken out the 3300 microfarad capacitor, which is a CAN type, and it is 3300, not 2200 like you find in the Harrier one. And we've replaced it with actually a better than. You have to take the clip out because the screws are silly way on. And at the same time I thought we'll have a look at the mains plug, which is an OK shrouded one. It's wired properly, but it had a 13 amp fuse in, so I've replaced the 13 amp fuse with a 3 amp fuse. So that's the way to go. I will do a pat test on this before we leave this bench. Use this handheld camcorder on my bench. We just transferred it. We did a test and we've got a problem with the insulation, so we'll just run through that test again just to show you on screen. Oh, right, well it yeah, right, well it failed, so that's interesting. So I think the problem is the main switch in that case. So I'll just show you the main switch, which is obviously all burnt contacts. Okay, well we'll deal with that behind the scenes, and we'll just go over now to the servicing video. Okay folks, so we saw the video on Mr. Chippie's bench and he'd done the capacitors in the power supply. What I want to do is to get on with the set. So we'll run it on 12 volts instead, which we would have done anyway. So we just need to plug into the DC input. I've got these connectors as you know, but have I got one on here? And the answer is I doubt it. So we'll sort the set out on 13.8 volts external. Now here comes the next problem. This switch. Or is it that wire off? Now the switch is mains. So that's a red herring. That's only mains. So once you've got it on DC, it will be on all the time. The fact it isn't on all the time is because that wire has come unsoldered. There's also white wire there which has been chopped off. There's also been soldering to the PA switch, and there's been so much soldering to the PA switch that clearly that no longer does PA, because it's just been turned into an on-off switch. So on-off of what, we ask ourselves? It's had a crystal filter fitted, and you just hope that that is the right one, because it's 10.695 IF. And you know what, I'm sure it says 10.695 on that, so that's great. And it's had the ballast resistor changed for a more heavy duty one, just as we would do. Turn the power off. We'll solder this wire on. So it's had a lot of silliness, hasn't it, in the past? I've not looked under the board yet. Perhaps I daren't. Of course, it's had a bash in the front, which is probably why that knob's broken. Okay, so now we are lit up. Oh yes, I'm knocking the power off, aren't I, because of the way the clips are. So we're on channel 20. We'll get our thingy in, test gear. Get our standard my standard Cybernet mic. I think the advertisement in eBay said it was working last time used. Well, it makes a noise. So we'll just quickly put the signal generator on. I got called away to the radio. This gentleman who does the vinyl covering, who was passing in the region, said hello. So we got the mic plugged in. I was putting something like the right frequency in the signal generator at 27.79125. We'll put picture in picture on and just complete that task. That's near enough. And yeah, oh, it's RF gain down. That's the broken knob. That's better. Turned it with a screwdriver. Right, does the set transmit? Let's have a look. So it must be on low power. Good grief. Does exactly 4 watts. That's had the ballast resistor changed, so that's good news. Save me doing it, won't it? Right, well, to all intents and purposes, it kind of works, doesn't it? So if we have a look at the VCO, it's channel 1 on these sets. We can put that on the main supply because that's not active. Oh yeah, it's had some soldering to that. Has it had some silliness that's been taken out? Let's just see what happens when you flick that switch. It's well off frequency. Probably another set that's been somebody's play toy. So the far side of that capacitor, and then transmit, and on channel 40, well, as ever I'm going to have to find a copy of the service manual because I can't remember the exact procedure, but it's certainly near enough for now. I'll tell you what we'll try and do, and that's set the frequency. We don't normally do that first, but it's quite well off, like the camera is. So we should be on 2779125. Well, we'll be on if we're on channel 20. It's 2779097. So it's not illegally off. This is where you find it's being broken. That's right. Yeah. You see, yeah, it's somebody's play toy, this set. That's broken. That's why it's off frequency. It's had the screwdriver in it. I bet they're all broken. What do we reckon? Okay, so it's going to be off frequency initially. So that's another task. We have to take it over to a different building to use the desoldering thing. Now we've got to find a scrap set with a suitable coil on it, you know, so it all goes on and on. Right, we'll go through the transmit lineup. And before we do that, we'll just see what the power output is on channel 40. It is 3.4 watts. And on channel 1, it's 3.6 watts. Did I misread it on channel 20 then? No, it's 4 watts on. Could even say it's 4.05. Right, so we'll go through these, especially if I put the right. We may end up having to order a new transformer from RS if that turns out to be have insulation problems. It's the centre. That's VCO. I nearly hit the wrong one. Just over 5 watts, and then you drop it. You don't drop it with that one. You drop it with this one. Get that down to 4 watts with the coil there. So we're spot on 4 watts. Let's see what we are on the other channels. 3.6 watts and 4 point something. So we need to change the waves then. Mr. Chippie's here for a question. Let's just drop it with that one. And then bring it onto channel 40. No, that's not really helped. Something's not quite there. I'll pause. So one of these is just on the edge of where we want it to be. It could be that one. Channel 1, 4 watts. Channel 20, 4 watts. Channel 40, 3.7. I just want to balance it that bit better. Channel 1 is slightly over. Hang on, we'll just straighten that coil up. Watts on channel 1, 3.7 on channel 40. Right, so we'll just... I hate it when this happens. Oh, that's probably about where we're going to be. So 3.9 watts on channel 40, 3.95 on channel 1. Oh, and it's 3.9 on channel 20, so we can bring it up a bit. Right, so 4 watts on channel 20, 3.9 on channel 1, and 4 watts on channel 40. Right, so the power consumption is 1.355. I forgot to write it down what it was before. We forgot to do low power, and it's now 300 milliwatts. Quick check of deviation, but I'll do that properly on the other test set. Wow, it's 3.2 on there, so that's quite possible what it is. I'll just pencil that in. I'll do all these meters and things later. So what we're going to have to do is I'm going to have to dismantle another sample. I've got to get all this wiring back right. Let's see if channel 9 does. No, channel 9 does channel 19. So that needs reversing. I just would like to know what PA does. Oh my goodness. It puts on a Roger bleep that makes it sound like selective calling. So I bet there's a Roger bleep board underneath which has got to come out. Alright, okay. I'm so thrilled. Can you see how thrilled I am? These are the people who, if you gave them a 1936 Rolls Royce, would cut the dashboard out to fit a CD player with a hacksaw. extension speaker is one of these. It's that one. Right, so we'll look at the receive as it is. Looks pretty decent, to be honest. It is 0.32. It's very good. Oh, I've got not showing you the right thing. And then for 12 dB, for 10 dB, sorry, it's 0.26. And for 20, it is 0.68. Squelch. It's a bit wishy-washy. It's capable of better than this. It's 8 microvolts tight. Now if this was the fake version of this board, like you get in the fake version of the Amstrad, then I could understand it being like that, the squelch, but it isn't the fake board, it's the real thing. These were £129 radios. .27. Right. See whether we can improve that at all. So with 100 microvolts on the signal generator, we'll look at the oscilloscope. And make sure we're recovering maximum audio. That doesn't feel right. It is the right tool. Was spot on, so that's okay. Let's go over to the Cybernet meter, just see whether we can get anything more out of it. Oh, got the squelch on, haven't I? That's interesting. We've got a filter and this doesn't look like it's set up right. Turn the signal down a bit. It's as if they just changed that without having a signal generator on it and doing the tuning. And we've got the hidden one under there. Alright, see what happens now when we look at the performance. So for 12 dB, I'm on the wrong scale. So for 12 dB we've got 0.21. For 10 dB got 0.2, probably slightly less than that. But we're between scales at that point. The 20 is 0.65. I'm just going to see if the S meter sets up. At the moment it's showing do 100 micro. I can't tilt this up to show you, unfortunately. It's not far out. It's 140 microvolts. So I'll put 100 on the signal generator. Just put the attenuator on so you can see what I'm doing. So we've got 100 on there. That's at 0, and then we'll adjust the S meter. For S9 like that, and then the squelch. So squelch to full, turn the preset till it disappears. 100 microvolts on a signal generator, hasn't come in. I want it to come in, so just drop that a fraction. Very fine on these. That's it, 100 microvolts. And this sensitivity, let's have a look. So here's one of the problems. We've got no squelch at no volume, in no squelch position, it's squelched. So we've got to back this off. That's probably why. Right, full squelch, try again. Well, believe it or not, I've still got 100 microvolts on it. But squelch isn't quite in. And again, full squelch. Best I can, absolute best I can achieve is 30. And at the sensitive end, .3. Right, we'll worry about the RF meter later. I'll have to do 1 or 2 repairs, obviously. We'll turn the power off. So basically the set's working. Oh, it's all been sealed so that you can't steal the Roger bleep. And there we have something to get rid of. and then we'll have to worry about the other things, the other connections. Well, clearly that switch is part of it. And then the other one will go to the mic, so we'll have to work out what they've done there. Good. So, another bit of rubbish for the vertical filing cabinet. That board really does need some cleaning up. It's had work around the phase like loop chip. It's had work around the audio IC. Anyway, it's going to have work on that coil, and we need to get rid of this diode matrix underneath, which is causing it to show 19 when we actually want it to select 9. So I'll probably get rid of those right now. And then there'll be a wire to move across to the instant access. You can choose 9 or 19 on the phase lock loop chip, so we'll have to do that. But this isn't going to be I thought this was going to be a 35-minute overhaul, and it's going to be one of those which is several hours. So I'm going to have to open up one of our sample sets to see how the wiring should be done, and then we can restore the public address function. So this is going to be part 1. So just to recap, we need to replace this coil, and we need to restore the public address function and clean up the printed circuit board to make it a bit more presentable. But it's transmitting at 4 watts, it's receiving beautifully. The squelch is how the squelch can be. And what else have we got? Yeah, restore public address. And we've also got to do the main switch. So the front's going to have to come on this. So I'm going to call it a day at that, because I wonder why it's bowed on the front. I mean, when I take the front off this, and it's like as it's been chucked into a skip, it's hit that point. Yeah, right. It's had display material out of something else. Never mind, we're getting there. So that's the end of part 1 of this Harvard H407 base station, which is now basically working. Thanks for watching.